Alright, what's up guys? It's Professor B and I'm back today with another physics problem. We're going to be doing some conservation of energy, so without further ado, let's jump into it. The problem says a 4 kilogram block starts with a speed of 12 meters per second at the bottom of a plane. This plane is inclined at a 35-degree angle to the horizontal, which means to the floor, and the coefficient of sliding friction between the block and the plane is mu sub k is equal to 0.32. Part A wants us to find the distance that the block travels up before it comes to a stop. And Part B wants us to find the final velocity of the block after it slides back down the plane. So before we jump into the equation, let's draw a diagram of what we have going on. So we can represent the plane as a triangle that's 35 degrees to the horizontal. So that's the block that starts at the bottom, and it travels all the way up before it comes to a stop. So my final velocity is going to be 0. My initial velocity is given to us, which is 12 meters per second. And they want us to find the blue distance right here, which is d. Now we can place our coordinate axis right where the object is. This is x and this is y. And it's just going to be tilted a little bit because of the incline. Now we can jump into the equation, which is k sub 0 is equal to u sub 0 plus w no u is equal to k sub 1 plus u sub 1. Now, w no u represents all conservative forces, and what I mean by that is air resistance and friction. In this case, it's just friction. So we're going to have 1/2 nv sub 0 squared plus mgh sub 0. And we can rewrite w no u as minus the force of friction times its displacement, which is equal to 1/2 nv sub 1 squared plus mgh sub 1. So they're giving us the initial velocity, which is 12. We know that the final velocity is 0 because the block comes to a rest, so we can just let that equal to 0. Now we need to find the initial height, which is h sub 0, and the final height, which is h sub 1. So how can we find that? Well, the initial height is going to be 0 because the block starts on the floor, and the final height can be rewritten in terms of sine. So we're going to have sine of 35 degrees is equal to this distance right here, which is h1, all over the hypotenuse, because we know that sine is opposite over hypotenuse, and the hypotenuse is the distance that the block traveled, which we can call d. So this would just be d sine of 35 degrees is equal to h sub 1. So we said that the initial height is 0, so we can take that out as well. And we can rewrite the force of friction as minus u sub k, mu sub k, times mg cosine of phi times delta x, plus, or equal to mgh sub 1. Now plugging everything in, we would have 1/2 times 4 times the initial velocity, which is 12 squared, minus the coefficient of friction, which is 0.32, times the mass times the gravity times cosine of the angle times delta x. Delta x is the distance that the block covered, which is the hypotenuse right here, which is also just d, equals the mass, which is 4 times gravity times the final height, which we rewrote in terms of sine, so it's d sine of 35 degrees. Now if we add this to the other side, we would be left with 1/2 times 4, that's 2 times 12 squared is equal to d. We would factor out the d, and we would have 4 times 9.8 times sine of 35 degrees plus 0.32 times 4 times 9.8 times cosine of 35 degrees. And if you put that into your calculator, you should get 8.7913 meters. And that is the distance that the block traveled before it came to a stop. Now, part B wants us to find the speed when it reaches the bottom. So let's draw another diagram. So the block is at the top, and the initial velocity now becomes 0 because the block came to a stop. And the final velocity is what we are solving for. So again, we just found this distance, which we're going to have to use. And we're going to need an h sub 1 and an h sub 0. In this case, the initial height would be where the object is, which is the block on the top. And the final height would be where we want to find its velocity. So placing the coordinate axis where the object is, we're going to use our equation that's k sub 0 plus u sub 0 plus w no u is equal to k sub 1 plus u sub 1. And remember that the angle is 35 degrees. So we have 1/2 nv sub 0 squared plus mgh sub 0 minus, remember that these are conservative forces, in this case it's friction that we are accounting for, therefore we can rewrite it as the force of kinetic friction times the change in x is equal to 1/2 nv1 squared plus mgh1. Now we know that the initial velocity is 0, so we can take that out of the equation. We know that the initial height is also 0 because we're placing the initial height to be where the object is. That means that the final height is going to be a negative distance. And I'll tell you why in just a second. So we can rewrite the force of friction as mu sub k times mg cosine of the angle times delta x is equal to 1/2 m times the final velocity plus mgh sub 1. Now, we can rewrite the final height in terms of sine, so we can do sine of 35 degrees is going to equal h sub 1 all over d. Now, because we place the origin right where the block is, all these numbers are going to be negative. And all these numbers are going to be positive. So therefore, our distance becomes negative. So we have a negative distance. Therefore, we have a negative 8.7913 sine of 35 degrees is equal to h1. Now, plugging everything in, we have minus 0.32 times 4 times 9.8 cosine of 35 degrees times the change in x. Remember we said it was negative, but because we have an absolute value sign, it becomes into a positive. So we have 8.7913, which is equal to 1/2 times 4. And the final velocity is what we're solving for, times 4, which is m. The gravity is 9.8. And the final height is a negative distance, negative 8.7913 sine of 35. Now, if we solve for the final velocity, we should get 4 times 9.8 times 8.7913 sine of 35 minus the coefficient of kinetic friction times the mass times the gravity times cosine of the angle times the change in x all over 1/2 times 4, which is 2. We take the square root of that. And if you put that into your calculator, the final velocity when the block reaches the bottom should be exactly 7.3257 meters per second. Thank you for watching.